Good day, students. How are you doing? This is me again, Sir Navarro, and welcome to our part 2 of solving quadratic equation using quadratic formula. So last video we talked about the derivation of the quadratic formula using completing the square. Today we're going to talk about, in this video we're going to talk about solving quadratic equation using quadratic formula applications. When is it applicable? So question is, when is quadratic formula applicable? So quadratic formula is applicable to any kind of quadratic equation. It can be incomplete or it can be complete quadratic equation. But the length of the solution really differs from the particular solutions or method that is more appropriate to those kind of situations. So if you use quadratic formula when the given equation is incomplete, like for example, the constant is 0, the solution will really be long, right? So when you solve quadratic equations, you have to be wise enough what kind of method is appropriate and is applicable to that kind of equation. Next is these are the steps in solving quadratic equation using quadratic formula. So basically, there are times that when a quadratic equation is given, it's not yet in standard form. So you always have to set it in standard form, right? And then after that, you identify the A, B, and C values. Because basically, if you cannot identify the values of these variables or A, B, C, if you will not write the quadratic equation in standard form, right? So after that, after obtaining the values, you have to substitute the values in the quadratic formula. And then, after substituting, you simplify the result. And then check the solution obtained using the original equation. Let's proceed to examples. Example number 1, 3x squared plus x equal to 10. So it's not yet written in standard form, so we have to write it in standard form, right? So it's 3x squared plus x minus 10 equal to 0. Next is, we have to identify the values. This A is 3, B is 1, C is negative 10. Then we use the formula the quadratic formula. Remember the song? Negative b plus or minus b squared minus 4ac all over 2a. Okay? Moving on, we substitute it here. Negative 1 plus or minus square root of 1 squared because b is a 1 there. Then minus 4 times 3. 4 times 3, that is negative 4 times 3, that is negative 12 times negative 10, that's basically plus. Okay, then 2 times 3 is 6. So 1 square is 1, then negative times negative is plus. So 4 times 3, that's 12 times 10, that's 120. Next is negative 1 plus or minus. If you add them together, it's 121, right? All over 6. And then negative 1 plus or minus, the square root of 121 is 11, all over 6. So since we obtained this one already, it's not yet the final answer. We have to separate the plus from the minus, right? And then we solve them individually. Negative 1 plus 11 all over 6, which is 10, right? 10 minus 1, or negative 1 plus 11, that's 10 over 6, which is 5/3. If you simplify it. And then negative 1 minus 11, that's all over 6, which is negative 12 over 6, right? And then this is equal to negative 2. After obtaining these values, we're not sure yet if these are the solutions. Okay? So to check if these are really the solutions, you have to do the checking. Right? So checking, for x equal to 5/3, you have to use the formula, the original formula, okay? This one, not the standard form, but the original given. So x equal to 5/3, basically that's 3, 5. This becomes 25 over 9. Then we can simplify it. It's 25 over 3, right? Then you add the numerators, 25 plus 5, that's 30 over 3 equal to 10, 10 equal to 10. So I did not write the question mark now, it will really take time. So just take note that above the numerator, it has a question mark. Moving on, for x equal to negative 6, 3 negative 2 square minus 2 equal to 10. Then if you square this one, this becomes 4. Then 3 times 4, that's 12 minus 2, that's 10 equal to 10. Let's proceed to the next example. 2x squared minus 5x plus 2 equal to 0. So this one is written in standard form already. So let's proceed to identifying the parts on A, B, and C. A is 2, B is -5, C is 2. Then use the formula. So negative times the -5 plus or minus square root of -5 squared minus 4 times 2 times 2 all over 2 times 2. And then after substituting, we simplify. So this becomes negative times negatives, it's plus 5 plus or minus -5 squared is 25 minus 4 times 2 times 2, it's 16, -16 all over 4. Then simplifying, 5 plus or minus, this is 25 minus 16, so that's 9, square root of 9 all over 4. So basically the square root of 9 is 3, right? So 5 plus or minus 3 all over 4. Then we separate the plus or minus and then solve the roots individually. 5 plus 3 all over 4, that is 8 over 4, which is 2. 5 minus 3 over 4, that is 2 over 4. If you simplify it, that's 1/2, right? So to do the checking, for us to see if it's really the solution, checking. For x equal to 2, 2 times 2 square minus 5 times 2 plus 2 equal to 0. 2 square is 4. -5 times 2 is -10 plus 2 equal to 0. 2 times 4, that's 8. Minus 10 plus 2 equal to 0. So 8 plus 2 is 10. Minus 10, that's 0. Check. The other solution is 1/2. So 2 times 1/2 square minus 5 times 1/2 plus 2 equal to 0. So if you square this one, this is equal to 1/4, right? And then 5 times 1, that's 5 times 1 over 2 is 5, -5 over 2. 2 times, you can actually cancel this one. So this is 1/2 minus 5 halves plus 2 equal to 0. So 1 minus 5, that's -4 over 2. -4 over 2 is -2. Plus 2 equal to 0. Check. So that means the solution to the equation is 2 and 1/2. Next example is -x squared minus 3x minus 5 minus equal to -5. So this is not yet in standard form, so we have to write it in standard form, which is, if you write it in standard form, considering that the quadratic term must be in positive, so I put it in here, x squared plus 3x minus 5. Okay, so then a is 1. Actually, you can also have the constant as positive. You see to it that opposite yung sign, but this one is positive yung quadratic term, so I always consider having a positive quadratic term. Moving on. So a is equal to 1, b is equal to 3, c is equal to -5. So actually, if you think of using the factoring method, if you think of the factor of -5 whose sum is +3, it doesn't exist. So that is why this is just one of the examples where quadratic formula is very flexible, not flexible, but it is well-rounded because it can do any kind of equation. Any kind of quadratic equation. So well-rounded yung quadratic formula. Okay, so because hindi lahat ng quadratic equation is masosolve ng factoring. Moving on, let's proceed to this one. After obtaining a is 1, b is 3, c is -5, we substitute it here. Okay? -3 plus or minus square root of 3 square minus 4 times 1 minus times the -5 all over 2 times 1. Okay? Then -3 plus or minus the square of 3 square is 9. -4 times 1, that's -4 times -5, it's +20 all over 2. So if you add them together, this is 29, right? So there are times that we cannot take the square root of this one. Although we can factor, some radicals can be factored, but there are some also that cannot be factored. Okay, so for example, 29 is a prime number, so there is no such thing as factor aside from 1 and itself. No, so yeah, it's a prime number. Yeah, it's a prime number. Along with 23 and 29. Okay, so after obtaining that, we separate the plus from the minus, and then this, since we cannot solve them, it's this form already. Otherwise, we use the, the decimal values of this. So, to do the checking, I use the formula. I use the decimal value. So the square of this is 1.4222252789, and then the value of this is this one. Then if I multiply this one by 3, this is the result. And then if I combine them together, this is -5, which is checked. Next is -3 minus square root of 29 all over 2. The same thing, but the value here is not the same with this one since it's negative na, right? So the sign really matters. -17.5774721, and then this one, -4.19258. So why are you using the whole decimal? So because the values or the decimal values matters later on. Okay, so -3. So this one is this becomes -12. Then -17. If you notice, the decimal values are just the same. So -17 minus 12, that is equal to -5. Oh wait, actually this is plus. Sorry, this is plus. Okay, -5 equal to -5. So let's proceed to the last example. So with the last example, you'll see later. So this is already in standard form. So basically, if you do the factoring to AC method, 2 times 3 is 6. But is there any factor of 6 whose sum is 4? 2 and 3, that's 5. 6 and 1, that's 7. So it doesn't exist. No, so we have to use the quadratic formula. A is 2, B is 4, C is 3. And then the formula, substitute into the formula, -4 plus or minus square root of 4 squared minus 4 times 2, which is A, and 3, which is C. So all over 2 times 2. -4 plus or minus the square of 4 is 16. 4 times 2 times 3, that's 24. Okay, that's negative all over 4. Then we subtracted it. We got -4 plus or minus square root of -8 all over 4. Remember the time that I asked you, is there any if you take the square root of a negative number, will there be a square root? It doesn't exist, right? So, but actually you can express this one, or sometimes you can simplify the radicand, okay, in this form. Remember that -8, it has a factor which is a perfect square. 4, if you multiply 4 with -2, it's -8. Then now we can take the square root of 4, which is 2. -4 plus or minus 2 square root of -2 all over 4. After that, we notice that 4, 2, 4, they have something in common, right? So we take them we factored out the 2 in the numerator. Okay? And then -2 plus or minus square root of -2. Notice reduce na siya. And then simplify na. So the result, -2 plus or minus square root of -2 all over 2. So we separate the plus from the minus. Okay? -2 plus square root of -2 all over 2. The other one is negative. For the checking, actually this one uses only the algebra method. So I didn't use the value so that you can see to it. So this one, if I square the numerator and the denominator, this becomes 4 minus 4 square root of -2 minus 2. You can use the square of binomial to this one. And then the denominator is 4. This one, cancel lang to. Okay. So now you can multiply it here. And then this one also cancel. Then moving on, we multiply them. 2 times -2 is -4 plus 2 square root of -2. And then this, if you simplify this is 1 minus 2 square root of -2 minus 4 plus 2 square root of -2 plus 3. 1 minus 4 plus 3, that is 0. Then -2 square root of -2 plus 2 square root of -2 is 0 also. Same thing with the other equation. If you see the solution, they're almost the same. Thank you and